Newton's second law of motion is expressed by the equation F net equals m, which is mass, and a, which is the acceleration, where F net is the net force acting on an object or system, m is the mass of the object or system, and a is the acceleration of the object or system. We want to apply this law to Atwood's machine, the standard form of which is a system of two masses connected by a string suspended from a pulley as shown in figure 1 below. The Atwood machine or Atwood's machine was invented in 1784 by the English mathematician George Atwood as a laboratory experiment to verify the mechanical laws of motion with constant acceleration. Atwood's machine is a common classroom demonstration used to illustrate principles of classical mechanics. The ideal Atwood machine consists of two objects of mass m1 and m2 connected by an extensible massless string over an ideal massless pulley. In this illustration, we can see the free body diagram of the two masses. m1 and m2 are the same in terms of gravity and tension, but they differ in acceleration. When we calculate the acceleration, we can use the formula gravity times m2 minus m1 all over the sum of m1 and m2. When it comes to tension, we can use m2 times gravity minus m2 times acceleration, or m1 times gravity minus m1 times acceleration.
Good morning, ma'am. I am Ralph J. Ferolino, and my experiment for today is about the Newton's second law of motion, specifically the Atwood's machine. So this is what I've made from earlier, and we will start the experiment. So we will hang the string with different masses on the hook with this pulley, and we will observe. Now I will release, and let's see what happens. So as you can see, the heavier mass is on the bottom side of the system and the lighter mass is on the upper side of the system. We can clearly determine that the net force is present on both of the masses. As what happened earlier, the heavier mass accelerates downward and the lighter mass accelerates upward. We witness that there is force, mass, and acceleration happening all throughout in the system, which justifies the principle of Newton's second law of motion. And I think that is all Thank you very much for listening and God bless.